Hi everyone, this is about the tutorial on inverse function. First question, here I'm going to check whether the function a, b, c, and d is a one-to-one function by using the algebraic method. And hence after that, we are going to determine whether the inverse function exists or not. Let's look at the first function. Fx equals to negative 3 over 4x plus 2. So to use the algebraic method to prove that this is a one-to-one or not one-to-one, we are going to define the two variable, that is x1 and x2, be the element of the domain of the fx. And after that, start from the equation fx1 equals to fx2. We're going to try to simplify this into the x1 equals to x2. If let's say the fx1 equals to fx2 implies to x1 equals to x2, then we say that it is a one-to-one function. Else, it is not one-to-one function, or we say many-to-one function. So substitute the x1 into the fx for the fx1. You're putting the x1 into the x here. You have a negative 3 over 4 x1 plus 2. And for the fx2, I'm going to substitute the x2 into the x here. You have a negative 3 over 4 x2 plus 2. Then we try to simplify. Both sides there are plus 2, so I can minus 2 at both sides. I got a negative 3 over 4 x1 equals to negative 3 over 4 x2. So now I try to eliminate the negative 3 over 4 by multiplying both sides by the negative 4 over 3. Then I will have x1 equals to x2. So since you say that, okay, fx1 equals to fx2 implies to x1 and x2, meaning that there is only one value of x bringing to one value of the y. At the first step, we are doing the assumption the value of y of the x1 and the value of y for the x2, they are equal, means that there is only one value of y. Then after that we have proved it. Seems like the x1 equals to x2, meaning that there is only exists one x bringing to this value of y. So we say that this is a one-to-one function, means that one x value bringing to one y value. That is the one object bringing to one image. So our reason is, since fx1 equals to fx2, this is the equation, implies to x1 equals to x2. Therefore, we say that f is a one-to-one function. The first sentence is our reason, and the second sentence will be the conclusion. So we are going to say that the inverse exists, the function. So we say that the inverse exists. For the second function, again, the step will be repeated. The same step you will apply to every question when you use the algebraic method. First, you define the two variables to be the domain of the function. And after that, you will start from this equation. Fx1 equals to fx2, as if that the y value for the x1 and y value for the x2 is equal. Then substitute the x1 into the fx. I have a square root of 9 minus 2x1. This is equals to 9 minus 2x2, when you substitute the x2 into the x. After that, I'm trying to prove that maybe it can be x1 equals to x2 or not. We are going to square both sides to eliminate the square root. I got my 9 minus 2x1 equals to 9 minus 2x2. Eliminate 9 at both sides. You got a negative 2x1 equals to negative 2x2. Finally, divide both sides by negative 2. You have a x1 equals to x2. So again, we will repeat the reason that we state just now. Since the fx1 equals to fx2, since this equation implies to x1 equals to x2, means that there is only one x bringing to one value of y. Therefore, we say that f is a one-to-one function. And since it is one-to-one function, that we say that the inverse of f exists. For this function, it's a quadratic function. We know that this is definitely not a one-to-one function. But now the question asks us to show by using algebraic method. We're going to start from the first step, that is defining the x1 and x2 be the element of the domain of the f, and we have start from this equation fx1 equals to fx2. Substitute x1 into the function. You got a x1 negative x1 squared plus 3, and fx2, it means that substitute the x2 into the function. You got a negative x2 squared plus 3. After that, simplify it by minus 3 at both sides. You got a negative x1 squared equals to negative x2 squared. And divide both sides or multiply both sides by negative 1. You got a x1 squared equals to x2 squared. And now you try to make the x1 into the subject, right? So x1 equals to positive negative square root of this. That will be x2. Okay, so since that x1, it might be equals to positive x2 or x1 equals to negative x2. There are two relations. Okay, our reason is fx1 equals to fx2. This equation does not implies to x1 equals to x2, because there is a other relation, that is x1 equals to negative x2. So we say that f is a not one-to-one function. All right. So function, we only have two, right? Only one-to-one or many-to-one. So not one-to-one means that is a many-to-one function. Then we say that inverse not exists. Inverse does not exist. Right. For the fourth function, that is fx equals to s cubed minus 4. So for the algebraic method, always we'll start from the same steps, defining this, and then start from this equation. Substitute x1 into the fx. You got x1 cubed minus 4 equals to x1 cubed, x2 cubed minus 4. Eliminate the negative 4 by adding 4 at both sides. You got a x1 cubed equals to x2 cubed. So take a cube root at both sides. That is x1 equals to x2. So again, you repeat the reason. fx1 equals to fx2. This is the equation that we use. Implies to x1 equals to x2. So therefore, we say that f is one-to-one. So you always can imagine the graph, all right? And the graph of the s cubed minus 4 is actually a one-to-one function. One-to-one function. And this means that the inverse does exist. Okay, inverse does exist. All right. For the second question, we're going to use either the algebraic method, all right, algebraic method, or the graphical method to show that whether the inverse exists or not. Meaning that from the algebraic method or graphical method, we're going to show it is either one-to-one or not one-to-one. So just now for the question one, I was already used the algebraic method. So here I'm going to show you the graphical method. The graphical method means that we need to use a horizontal line test. It's very simple. The most important prerequisite knowledge for the horizontal line test is you must know how to sketch the graph. So the graph sketching is very important for the topic function. Look at the question 1. We have a function y equals to, fx equals to 2x. For the fx equals to 2x, this is a linear graph. Okay, linear graph where if this is a y equals to x, okay, compared to the basic graph y equals to x, it is a little bit slant. Okay, a little bit the gradient is higher than the y equals to x. So we need to draw a graph, a straight line, which is steeper than the y equals to x. So I label this as my y equals to fx. Okay, or you can say that y equals to 2x, no problem. So you need to label the y axis as y and the x axis. After that, we are going to test by using horizontal line test, meaning that drawing any horizontal line and shows that your horizontal line is actually passes through only one point. Cuts the graph at only one point. You can draw another horizontal line, and this horizontal line also passes through the graph or cuts the graph at only one point. So you must show the horizontal line test and give your reason. It says that since each of the horizontal line cuts the curve y equals to fx at only one point, therefore we say that it is a one-to-one function. Therefore f is a one-to-one function. And since it is one-to-one function, we say that the inverse of f exists. Okay, now we proceed to the second example. Okay, so label your graph. Okay, x and y axis. So for this quadratic function, you got actually x squared minus 6x now already been factorized. It's easy for us to find the x intercept. Okay, so we can let the fx equals to 0 in order to get your x intercept. That is your x minus 6 equals to 0. You solve it, you got the x intercept as x equals to 0, x equals to 6 as your roots of the function. So it means that your graph will passes through 0, 1 point, and x equals to 6. Okay, as if that your 6 is over here. And looking at the coefficient of the x square, the coefficient of the x square is positive, right? So the shape of the graph, it should be having the minimum point. So you know that the graph is in this way. You go down, reaching a minimum local minimum point, and then you go up again. Okay, so if you want to know the minimum point, very simple. You can actually do the completing the square, or at the minimum point that will be the axis of symmetry. That is in the middle of the in between 0 and 6. That is 3. You can just substitute 3 inside here. Okay, to get the value of the y. So 3 minus 6 will be negative 3. Negative 3 multiplied by 3, that will be negative 9. Meaning that at x equals to 3, this will be negative 9. That will be your minimum point. You can always check by completing the square. Then from the completing the square form, right, you can actually get this minimum point. Okay, so now you can just label this as your y equals to fx. So having this horizontal line test, we're going to sketch any horizontal line. Just putting any horizontal line on your graph, and shows that it passes through the graph at 2 points. Then you can directly make your conclusion since the horizontal line Okay, so this is my conclusion. The horizontal line passes through the curve y equals to fx at more than 1 point, or we say 2 points. Okay, then f is not one-to-one function. Therefore, we say that inverse does not exist.
Continue for this function. I'm going to sketch the graph of this. We can sketch this graph by having the basic function. The basic function is y equals to x cubed. It's like that. And since we start from the y equals to x cubed, and then continue by the y equals to 2x cubed. Yeah. By multiply this x cubed by 2 means that the gradient, or we say that the graph will be a little bit steeper compared to the y equals to x cubed and go down a bit faster. So you can just erase there y equals to x cubed, and this is still y equals to 2x cubed. And having addition of 1 unit, so your graph will go upwards for 1 unit, meaning that your graph will be like this. Okay, it will go up 1 unit, meaning that at this origin, the point of inflection originally is at the origin, so now it moves to the 0, 2. Okay, so the graph will be like this, and you can erase off this y equals to 2x cubed. Label this as a y equals to fx. Now, this is the this is 1 unit, yeah, because the graph is pulled up for 1 unit. And if you want to know this graph, you can just substitute the y equals to 0. You got 2x cubed plus 1 equals to 0. X cubed will be equals to negative 1 over 2. So x will be equals to cube root of negative 1 over 2. You can just label this point as a cube root of negative 1 over 2. It's okay. Alright. Then after that, I'm going to show that this is a one-to-one function by using the horizontal line test. So having the horizontal line, I sketch a horizontal line, and you can see that this horizontal line passes through the function, the curve at only one point. You can have another horizontal line, and again, this horizontal line passes through the graph at only one point. If you sketch a few more horizontal lines, you will get the same result. So your conclusion is the same as the previous one. Okay, this copy paste from the previous conclusion. We say that since each of the horizontal line cuts the curve y equals to fx at only one point, so f is a one-to-one function. So we say that inverse of f is x. For the function 1 minus square root of x, I will start to sketch the graph y equals to square root of x. That is our basic graph of the third function. This is a y equals to square root of x. When you have a negative followed by, I will sketch a negative of the square root of x. Negative or square root of x, it will have the graph which it will reflect it about the x-axis. Alright, this is a y equals to negative square root of x. And you can erase off this basic graph. So from this y equals to negative square root of x, I will continue by sketching y equals to negative square root of x, and then add 1 unit to the y. You get a negative square root of x plus 1, which is the function of fx. So meaning that our graph will go up for 1 unit. We can refer to this reference point. Go up for 1 unit, you will have this, okay, at the point of 0, 1, and then the shape still remain unchanged. Okay, so this is your y equals to fx. To test this graph, okay, having this one-to-one function or not, we always can use a horizontal line again. Use a horizontal line, we sketch any horizontal line on top of the function. Alright, you will see that your horizontal line passes through the graph at only one point. This is the point that it passes through the y equals to fx. And draw another horizontal line to show that the horizontal line always passes through the graph at only one point. Then our conclusion again will be like this. Just now, I'm copying this conclusion. Alright, and then this is my conclusion, the same as the conclusion just now. Yeah. Each of the horizontal line cuts the curve for y equals to fx at only one point. So f is a one-to-one function, and this means that the inverse of f is x.